When you think of a satellite, you probably imagine something massive and expensive, right? But what if I told you that some of the most advanced space missions are powered by satellites no bigger than a loaf of bread? These are CubeSats, small modular satellites that are changing the game in space exploration. In this video, I'll show you how these tiny powerhouses are making space more accessible, affordable, and innovative than ever before. CubeSats are standardized small satellites. A single unit, or 1U, measures just 10 centimeters per side, which makes it about the same size of a Rubik's Cube. These modular satellites can be combined into larger configurations, like 2U, 3U, and even 12U, depending on the mission's needs. The first ever CubeSat CP1 was developed in 1999 by California Polytechnic State University. Its purpose? To provide students and researchers with a low-cost platform to test technology in space. Fast forward to June 30, 2003, and the QuakeSat became one of the first CubeSats to be launched on a Russian rocket launch vehicle alongside other university CubeSats. This particular CubeSat had a mission to detect electromagnetic signals that might precede earthquakes, and managed to successfully detect ELF waves that were produced by earthquakes. As of today, over 2,300 CubeSats have been launched into space. CubeSats didn't stop at Earth orbit. In May 2018, NASA's Mars Cube 1, or Mark 0, became the first CubeSat to venture into interplanetary space. This mission involved two twin 6U CubeSats, Mark 0A and B, also nicknamed Wally and Ava. These CubeSats were equipped with solar panels, a radio receiver, and transmitters, and had the mission to relay real-time data from NASA's InSight lander as it touched down on Mars. These two CubeSats proved that CubeSats could operate independently in deep space, a milestone that opened new doors for exploration. So, what makes CubeSats so revolutionary? Let's compare them to traditional satellites. Traditional satellites can cost hundreds of millions of dollars to be built and launched, on average $200 million. However, CubeSats are tiny and cost-effective, often built for tens of thousands of dollars, which is but a fraction of the cost to make a traditional satellite. This affordability has democratized access to space, allowing universities, startups, and even small countries to launch their own space missions. Take Chesky 1, for example, the first Peruvian satellite. This 1U CubeSat was equipped with cameras, solar cells, and communication systems, enabling Peru to participate in space exploration by taking pictures of the Earth and transmitting them to the ground station. All of this at a fraction of the cost of traditional satellites. This is a perfect example of how CubeSats are lowering barriers to enter into space. CubeSats are already delivering results. The Mars Cube 1 mission proved that CubeSats could operate independently in deep space, relaying data 54 million kilometers away. Meanwhile, NASA's lunar flashlight is uncovering the moon's secrets by searching for water ice, paving the way for future missions like Artemis to explore and sustain human presence on the lunar surface. These tiny satellites are not just technological marvels, they're a tool for global progress. Thank you for watching this video, and I hope it's inspired you to see how even the smallest innovations can make a big impact.